Hello everyone. Welcome to the next lecture on the quadratic form part C solution. Myself Dr. Harish, I will cover these questions taken from the July 2025 examinations. You can follow my YouTube channel where you can find the playlist of the CSR UGC NET. In this playlist, you can see the complete lectures available related to the CSR NET July 2025 solution. You can follow and subscribe my YouTube channel. Now you can see this is the question related to the quadratic form asked in the part C and how you can solve within the 1 minute time period. Very simple form. First of all, what is the non-degenerate symmetric bilinear form? If you define the matrix B, fine, which is my quadratic form, then this matrix is said to be is a quadratic form. This matrix is said to be the non-degenerate bilinear form whenever the determinant of B is my non-zero. That's the meaning of the non-degenerate symmetric bilinear form. Fine. Now, what is the given statement is, if you have the two vectors V and W such that V and V are my 0, these two numbers are my non-zero. If I call this number is my A, this number is also my A. Then which of the following statements are my necessary true? Look at the first part. B and B, if I look at this number is my X. Is X is always 0? Now you can see my condition is determinant of B is my non-zero. So either X may be 0 or X may not be 0. Fine, because what is the determinant? Determinant, you can see it is minus A square and it is independent of the X. So that means X is equal to 0, not always true. It is necessary, it is not necessary true. Fine. Now, second thing, because the determinant is my non-zero, what is the meaning of that? Eigenvalue is my non-zero. Whatever the eigenvalue you have obtained, now you can see, if you look about this is the if and only, fine. Now, if you look about that Q is equivalent to, if you write the quadratic matrix Q, then it's X square minus Y square and the rest values are my 0. Clearly say the determinant is my non-zero, or because it is my non-degenerate, so that means you can see the matrix, the quadratic form is my indefinite. Clearly say the eigenvalue is my positive, eigenvalue is my negative. Therefore, this matrix is my indefinite. Yes, this is equivalent to the non-degenerate symmetric form. Now, look at the third option. Second and third option, there exists alpha belongs to the R such that Q of alpha V plus W is equal to 0. What is the Q? Q of V is my V, alpha V plus W, alpha V plus W is equal to 0. Because alpha is my real numbers, if you open them, it is alpha into alpha, alpha square, B of V comma V plus alpha into alpha is the outside, V of W plus alpha V of W into V plus B of W into W comma is my 0. Fine. Now since it is given that B of VV is my 0, that number is my 0. Fine. Again, the matrix is symmetric. Therefore, the quadratic form B of V comma W and W comma V are same. So both these numbers are same. I can write as a 2 alpha V of VW is equal to minus. Fine. Now because W and W may not be 0, so I can find the value of alpha, which is a unique number. Why? Because clearly say the denominator part is my non-zero. So that number may be 0 or may not be 0 depending upon the value of B, W comma W is 0 or not. And clearly say this is the unique number because the degree is 1. There exists, yes, there exists. He said infinitely many is not possible. Right answer is my 2 and 4 are the correct answer of the problem. You can see it's always a very simple form of the quadratic term. You can see the part B solution of the quadratic form. I already uploaded the part B solution of the quadratic form in this playlist. You can follow and easily subscribe my YouTube channel. Let me know in the comment box whether you can like and comment this video or not, and whether you are interested to watch the next lecture on the part C of the linear algebra or not. I'm waiting for your comment box. Till then, you can share this video with your friends, like and comment on the video. Happy learning always. Best wishes.